spec, some of the stuff you've seen before, and some of it might be new to you. So let's talk about the thing that is probably familiar to all of you, and that is the Pythagorean Theorem. And most of you are pretty familiar with this. You've used it before. And the Pythagorean Theorem applies to what type of triangles? In a right triangle. So what the Pythagorean Theorem says is, in a right triangle, the sum of the squares of the legs, and in a right triangle, the legs are the two shorter sides, or the two sides that form the right angle, and then the longest side is the hypotenuse, also referred to as the side that's across from or opposite the 90-degree angle. But in a right triangle, the sum of the squares of the legs is always equal to the square of the hypotenuse. And most of you are aware of this in an algebraic form, or in the form of an equation. And usually it's designated with AB as the lengths representing the legs, and C the length representing the hypotenuse. And the equation is a squared plus b squared is equal to c squared. Okay. So this is the Pythagorean theorem. I'm guessing most of you have done some kind of calculations with this before. And what I want to do really quickly is, one, make sure you see how it's worked through by hand, but most importantly, how the information is going to be entered online if you have to write an answer that's not an integer value. Okay, so let's say I gave you the following example. So I have a right triangle. One side, one of the legs is a length of 1, the other a length of 2, and I'm asking you to solve for the hypotenuse, which I'll designate as the unknown x. Okay, so if this is the case, you would set it up using the Pythagorean theorem of the sum of the squares of the two smaller sides of the legs is equal to the square of the hypotenuse. So 1 squared plus 2 squared is equal to x squared. Now, you don't have to put the legs in any particular order. What you'll generally see me do is I'll usually try to put the smallest leg first, but it doesn't matter. It can be either one. But once you get the elements substituted in for the Pythagorean theorem, you just solve your resulting equation. So 1 squared is 1, 2 squared is 4, and that's equal to x squared. Continue to combine and simplify. Add your 4 and 1 together. You get x squared is equal to 5. And then you can solve for x by extracting the square root. And normally when you extract the square root, you need to take into consideration both the positive and negative root. So here x can be both a positive or a negative root 5. But because we're dealing with the lengths or a distance here, can we ever have a negative distance? No. So we're just going to use the positive of that. So our answer winds up being square root of 5. Okay. When you submit your answer, the way that you would enter this answer online is you would enter it as SQRT parentheses 5. Whatever is inside your square root will be inside parentheses after SQRT to designate the square root. Okay. Now, the one place where this may tend to cause some confusion is if you had the square root of 50. And because if you wrote SQRT 50, it would not register as the correct answer. And the reason for that is you need to always make sure your radicals are simplified as far as they can be simplified. And so if you recall from algebra how to simplify by hand, we look for perfect square factors that we can remove from this number. Only perfect square factor from 50 we can remove is 25. So square root of 50 is equivalent to root 25 times root 2, and root 25 can be simplified to 5, where the 2 stays inside the radical. And so when you enter this online, you would enter 5 SQRT. Now it's just the 2 in the parentheses. So this would be the correct form rather than SQRT 50. And so make sure you simplify it completely. Your calculators, if they're set in auto mode or exact mode, will do this for you. Okay, so the square root form is called, on your TI-89s, it's called exact mode. And so there may be some times where it asks you to round to a certain number of decimals, other times where it asks you for the exact answer. Exact answer means enter SQRT if necessary. Okay. All right, if we take a look at a second example, so we may have the hypotenuse as our unknown, or we may have one of the legs. So let's take a look where we have a leg as an unknown. And I want you to see if you can come up with the value of y in this example. We have a leg of 4, hypotenuse of 5, an unknown leg designated y. See if you can find what is the value for y. Right, when you set this up, because one of our legs is unknown, I'm going to start with that. We get, y squared plus 4 squared is equal to 5 squared. And so if we simplify everything, we can square the 4, square the 5, solve for y. So we isolate our y term by subtracting 16 from both sides. When we subtract 16 from 25, we get 9. If we extract the square root, again, algebraically you test the positive and negative root. Here, because we're dealing with the lengths, negative roots is not going to work, so it's just the positive root. Square root of 9 is 3. Okay, so you wind up with your answer of 3. Okay, now,